Hey everyone, this is PKS. Welcome back to my channel. Today I'm going to take a system design mock interview, and we have Jyoti Verma with us. Today we are going to design Instagram. So welcome Jyoti to my channel. It would be appreciated if you can introduce yourself with our audience.
Yeah, hello everyone. Hi Pradeep. Thank you for having me on your channel. My name is Jyoti and I'm currently working in Walmart as an SD3 and I have around 3 years of experience and currently I'm working here as a full stack developer.
Great. So, welcome Jyoti again. And today's question is design Instagram. So, it would be great if you can share your screen and note down the functional and non-functional requirements.
Yeah, sure. Yeah, is it visible?
Yes.
Yeah.
Okay. So when we think about Instagram, so definitely the first functional requirement we can say uploading reel of 60 seconds to 120 seconds, that is 1 minute to 2 minutes.
Okay, user should be able to upload the reel. Be able to load reel and should be of 60 seconds to 126, right?
Right.
Okay.
Max you can consider ki 120 second is max.
Okay.
And the second is user should follow and following each other.
User
That
should be able to
yes,
follow
that
together.
means followers and following feature we should have.
Okay. Yeah. That's good.
And the third is if let's say one user follow someone, then definitely a feed should be visible to that user, and the post or the video should come into that feed.
Okay. And the ordering is also important. Like latest one should come at the top.
Yes, absolutely. So latest video should come on top.
Okay. Okay. Yeah, that's all.
Yes, I think we are good enough to going forward.
Yeah, okay. Let's write some non-functional requirement as well.
Yes, so in non-functional requirement, the first one should be the services should be, or you can say the system should be available 100%.
Okay, should be available. And what of consistency?
We can go with the eventual consistency because in Instagram, the upload service should never stop, right? It should be never down.
Okay, so eventual consistency. Okay, okay.
Yes.
And
We
how
can
many?
try, we can try with the 99.9% consistency, but yes, I am happy to take eventual one.
Okay, and how many users are there?
So you can consider we have a good scale. That means system should be scalable, and we have 10 millions daily active users. So 10 million DAU.
Okay, 10 million daily active users. Okay, and the system must be fault tolerant as well, right?
Right. System should be fault tolerant, and I expect all the API should must have low latency.
APIs must have low latency. Okay.
Right. So you have to think about the read and writes, right?
Okay. Okay. So is
But
this look good to you? Functional and non-functional requirements.
yes, it's looking good to me.
Okay. Let me write the core entities of a system as well.
Okay.
Core entities. So first thing I'm noticing is our user. That is the main part, right? So
Okay.
the users which are present in our system, users in our system. And then we have our post, which is basically we are considering reels for now. So the post reels which user will upload and follow. Basically, it is kind of a unidirectional link between our system, right? User must be can follow each other. So unidirectional link between our system. Okay, so I think this is good enough as to core entities. Let's do some capacity estimation as well.
Yeah.
We can able to judge which database we will use. So capacity estimation. Okay. So you said there are 10 million daily active users, right?
Right.
And how many uploads we can see?
So you can consider 1 million daily uploads.
Okay, so 1 million daily uploads. I see. Okay. So 1 million are daily uploads. Okay, and video length maybe will be around like you have said 60 seconds and maximum is 120 seconds, right?
Right.
Video length. So I will take maximum of 120 seconds. Okay, and so if we're doing it in high resolution, it takes 100 MB per video.
Mm-hmm.
We're storing it in high resolution. Let's suppose takes 100 MB per video space. Okay. So if we have to take the daily storage requirements, so it will be around daily storage requirements. So it will be around 1 million uploads. So that is 10 raised to power 6 and into me 200 because one video is taking 100 MB.
Okay.
So 1 million will take around 100 terabyte per day.
Yes.
Okay. And if we have to calculate the monthly storage, we are storing monthly reels, then it will be around 30 to 100 terabyte. So it will be roughly around 3000 terabyte.
Right.
So 3000 terabyte. So it will be, I guess, 3 petabyte per month.
Yes.
Right?
Yes.
So if this looks good to you, capacity estimation.
Yeah.
Okay, so we are done with our capacity estimation as well. I'll keep it here. Just here. Okay. Okay, so now start with our high level diagram.
Okay.
So first thing we will be having is our clients which are using our system. So let's draw it. So first thing will be our client, and they can use our Instagram from web, Android or iOS, anywhere, right?
Yeah.
Android or iOS. Then what we can do, we can place an API gateway. So we will place our API gateway here. So our API gateway is basically responsible for our load balancing and load balancing and basically doing the routing, and we can use it as a rate limiter as well. Okay, so yeah, so this is our API gateway. And then first service in functional requirement is user should be able to upload the reels, right? So for that we need a post service which is basically responsible for taking reels from the user, and user will click on the upload button. So that upload button, what will do, it will store that reel in a storage, right?
Okay.
So what I'll do, I'll make.
If you don't mind, can you increase the zoom size of the screen? This is 67%. Can you? This is fine. Or we can go with 90%. Like.
Okay. Okay.
This is fine.
So I'll make a post service.
Okay.
This is my post service. So this is responsible for adding my reels into my storage. So for storage, I'll take two kind of storage. First will be the blob storage. So basically where we will keeping our reels, and for putting the video metadata, what we can do, we can take another NoSQL database, which will be responsible for storing the metadata of the video.
So what kind of NoSQL database you will prefer to store metadata of video?
We can store it in Amazon S3 because they have key value type of pairs. So in the key, what we can do is we can write the video ID, and in the pair we can store all the metadata, whatever metadata we will have in our video.
Okay, so no, I'm talking about the metadata. So you are saying Amazon DynamoDB?
Yeah, yes, Amazon DynamoDB we can take, and for storing the video, I will prefer Amazon S3.
Okay, so you will store original source file in S3, and what about the metadata?
Yeah, we can choose DynamoDB for that. NoSQL database. Yeah.
Okay.
Okay. Then trips. So I'll take just two things. So first will be my Amazon S3. It will be we will be storing the video, original videos in Amazon S3, and we can store metadata in a DynamoDB. So I'll choose. So let me write just video metadata table for now.
Okay.
Video metadata table. Okay. So this is our post service. So we'll be storing it here, and also we will storing our metadata in our this. Is this looks fine to you?
Yeah.
Our functional requirement is, then we the second functional requirement is users should be able to follow each other. So for that I'll make another service which is responsible for following the users. So basically if user hit like follow button for other users, so we have to store it somewhere, right? User X is following user Y. So in the user X we should know like to whom he or she is following. So for that, we can create another follow service, which is basically responsible for the following.
Okay.
Okay. So I'll just make a follow service here, and if you use a click on follow button, it will come to the follow service. And for follow service, we can have follow table, basically, which is responsible for storing, like if user X is following user Y, so in user X we will store to whomever he or she is following, the list of the users.
Okay. So since it's a another microservice, you want to store some in other database, right?
Yeah.
Okay. So what kind of database you will prefer to store this?
Key value pair, or basically what we can do is, yeah, we can, yeah. So key value, we can use same Amazon DynamoDB. And to have the feed service very fast, what we can do, we can store it in cache also, like for
Okay.
some of the users. Yeah. I'll name it as follow table. What I'll do. Okay.
Mm-hmm.
Now our two functional requirements are done. Then third functional requirement is users should be able to view a feed. Okay. So for generating the feed, what we can do, we can have a different service, basically, which is responsible for generating the feed, because we have to generate the feed at very high speed, right? At very low latency. So I'll make another service for that. So I'll make another service. So this is the feed service, which is basically responsible for generating the feed for a user. So so from where our feed gen service can be generated is basically, first thing is, for generating the feed, we should know the particular user for which we are generating the feed, to whom he or she is following, the list of the users. And whatever they have like posted something new, so that should come in the feed, right, at very first place.
Okay.
So for that, what we can do is, so for the post service, we have added the reels in our Amazon S3, and what we can do is, we can place a CDN here.
Okay.
Right? So I'll place a CDN, so that for generating a feed, what we can do, we can take that from the CDN, like all the videos and all. So in CDN, what I'll place, so it will act like a cache for us. So what I'll place for a user, to whomsoever he or she is following, the list of the users and the photos and the videos that they have posted recently. So we'll take that from the CDN itself and serve feed of the users.
So you mean to say when a person should upload a video, it should go to S3, then a CDN, right?
Yeah, we should place it in CDN as well. Like we have to update it.
So do you believe we also, since maybe it has different devices, right, as a client, so I believe transcoding is also required, right? So that every user should have a great experience on even on a lower bandwidth. Maybe somebody has a low internet, right? So I believe transcoding is also required.
Yeah, so what we can do is, we can place like videos in different resolutions in our CDN. So for that, we can have basically a different service which is responsible for doing the transcoding and placing it in our CDN. So while posting itself, what we can do.
So basically, AWS has a media elemental service, right? AWS Media, right? Media Convert. So I think that name is Elemental. So we can use that particular service. This is for our audience, basically.
Yeah, we can use any of the service, like which is best for our use case. So what I can do is, like, there can be multiple users, so it is possible the transcoding service will take some time for transcoding it. So what we can do, we can place a queue here, like what we can do, we can use Kafka and anything. So this service will be responsible for adding it in our queue, and then from queue we will add that in our transcoding service, and that after the transcoding is completed, we'll place it in the CDN, so that video that is going.
In that post service, basically, you mean to say ki, you will upload a source file and get the path and some metadata and the path you will send to queue. Is that mean to you?
Yeah.
Okay.
And I'll add a transcoding service here, so which is basically responsible for transcoding our video. Then we'll place it in a CDN.
Okay.
right? And from CDN, what we can do, we can generate our feed.
Okay.
So from CDN, we'll generate our feed so that it will be very fast because we need right 100% availability. So yeah, consistency. Basically, we are okay with the eventual consistency, but our system should be highly available. So our system should be highly available so that it should be fast, right? Where loading time will be should be very less. So for that, what we can do, we can basically fetch our data from CDN itself so that it will be very fast.
So in feed, basically we get the video data, and since we have a follower service, okay, so we also fetch user related data. Okay, that is the following table. That's fine. Okay, that looks good to me. Can you provide me APIs and any specific reason to choose Amazon DynamoDB?
Okay, so let's start with the API first, then we can discuss it later.
Okay.
So yeah, you are saying APIs. So okay. So first, let's discuss on the API. So the first API which we'll need is like for first thing is user must be able to upload a reel. So we'll need a post API basically that is responsible for creating a post, right, and
Okay.
uploading the. So I'll just make this API. So that is responsible for, let's suppose, the post API and uh, create. Okay. So
Okay.
in its header, in its request, in its content, what we can add the content, whatever we have uploaded, right? Whatever the
Mhm.
user have uploaded, the reels, the reel details. So I'll add the content here. Let's suppose, and so in its response, what we can place, we can turn the post ID, right? From the post ID, we can get whatever the content is uploaded and whosoever have uploaded that content, right?
Okay.
So in the response, we can have post ID. Okay.
Okay.
Okay. So first API, is this looks good to you?
Mm-hmm.
And okay, first API, first for first functional requirement we are done. Then is we should be no user should be able to follow each other. So we will need this follow API. So for that, what we can have the post API, and we can give the user, and we can place the ID to which she is following, and we can have the follow, right?
Okay.
Is that it is a follow request, and we can place the request here, right?
Okay.
User is following each other. And third API which we need is user should be able to view a feed. So for viewing the feed, we need a API. So I think that will be a get API, right?
Okay.
So what we can do, we can have a get feed. So that is responsible for giving us the feed, and we will get in the response basically the list of the post, right? All the
Okay.
which we have to show it in the front end, right? So
Mhm.
in this will get the array of like post, right? So I
Okay.
think these three APIs are good enough, and it will handle all our functional requirements.
I think we need one more API na? In followers specifically, if we need to check this user is follow or not.
Yeah, so this is responsible for like if user click on follow button, then only should be able to follow, right? So this
Right.
is
That is
responsible
the
for.
create request, right? Key this follow or this one, right? But for every for an example, I need to check if somebody is following or not. So that is also we
This
need to check. Let's say if you are checking some third person which you are not following, right? A user can check any profile, right? So maybe we need to call our API that will give us status, are you following this user or not? So maybe a simple, you have to give a user ID and check in database, and that API will give you response like false, something like that.
Okay. So we can get the follow request for, okay, so what we can do is we can pass the user ID from there, right? And we can have the follow, right? So it is a get. So it will basically return boolean, true or false, whether we are following for that particular user or not. If you just want to check, right?
Mm. Similarly, I also need a GET API to, since you mentioned you need to send the all data to SQS. So on a scale, first you post the content and then data goes to S3. Then you need a GET request, right? Or something like that so that you can fetch data, or you want to do in async mode, what exactly? Or you want to create some another API to get the path, or I think you mentioned somewhere SQS. Can you show the design, please? Yes. So in post service later on, when we are talking about the CDN, you put the queue. So what do you think about how you put the data from data put to S3 and sending data to queue or some Kafka? So in
Yeah,
which you directly putting Amazon S3 and directly send to the queue, right? No
yeah,
specific.
yeah,
Okay. Okay, let's move forward. So I think it would be great if we can discuss about some trade-offs of this design. So my first question will be how we can ensure, or any specific reason to choose Amazon DB, because if you go with Amazon DB, then definitely it will be costly, right? Because Amazon DynamoDB is a paid service of AWS, right? So any specific thing in your mind?
Okay. Any specific thing? No, I don't have anything specific because in this, why I have not chosen SQL databases, like we have the users and for the videos, and we can have different metadata. Our
Right.
schema is not defined, so we
Okay.
have gone through. Yeah, there's no SQL data type, and Amazon S3 is basically helpful in handling large number of users. We can shard it, right,
Mhm.
easily.
Okay.
Yeah,
So the scaling was in your mind. So you thought, ki since data, the number of daily uploads pretty much high. So
yeah, yeah,
you thought you have a horizontal scale, and so that's why you have choose to basically scale over the course, right?
yeah, yeah, yeah.
Okay. And since you used API gateway, okay, you implemented queue as well. I think overall it's a good design. But what about when we talk about the feed, right? So we have a CDN where the data, I can say the video and video metadata is present, but maybe somehow we have to call follow service and feed, or maybe some user data. So you also maintain user entities, but okay, you did not mention where you will store the overall user or user profile data. So I believe as per the requirement, you did not design in that, might be. So definitely, so how you store user or user data? Will you prefer to choose some relational database like MySQL and Postgres, or something in your mind
Yeah,
for the
for user
user?
data, we can go with the MySQL database because it also provide our ACID properties.
Mhm.
So yeah, for that we can store and we have predefined data for users. So that's for user data we can go for SQL database.
Okay. And the one last question, that is how you authenticate these services, because authentication is the most strong thing. And how do you basically, since you mentioned API gateway, so you mentioned load balancing, routing, and rate limiter. I believe that's good. You already mentioned these things from the API gateway, but I did not see how you do authenticate a service. Will you
Yeah, so
use?
from here only we can do the authentication. Our API gateway here will write authentication. That will be responsible for authentication as well.
Okay,
That's
so you will definitely use some authentication algorithm, and then authentication service, and that will, I think, return a GWT token, and use that particular token. You can use.
authenticate a user. Yeah.
Okay. So I'm good at my side. I think it's good to our audience. Jyoti, thanks to come here, and overall, it's a good design.
Thank you so much, sir.